Hello, class. This is a recorded lecture for stats on section 6.2, which is our first introduction to what's called statistical distribution. And so the first one that seems to always be introduced is what's called the binomial distribution. And so we'll walk through how do you know if the data fits a binomial distribution, and then calculations on how to use the binomial distribution to make predictions, and then also being able to calculate the expected value or mean and the variance and standard deviation as well. So with that, let me shoot over here to the presentation. And you could see that section 6.2 in the book. And we'll walk through all of these objectives here. Computing binomial probabilities. Highly, highly recommend that you use technology to help you with this. There is a formula. It's quite complicated. I'll show it to you once. But again, as I've said before, nobody calculates this by hand anymore. You either use your fancy calculator or a spreadsheet as well. So first we want to introduce what we mean by a binomial distribution and the random variables associated with it. And I have to admit, the book does a good job in this section. So take a look at the book if you need a little bit more information. But this is a really good example. Suppose that your favorite fast food chain is giving away a coupon with every purchase of a meal. So you get this coupon, and 20% of them give you a free hamburger, and the rest of them say, better luck next time, right? So 10 of you go and order a lunch, and suppose you want to know the probability that 3 of you win, or greater than 5 of you win, or less than 3 of you win, etc. This is a binomial distribution. And so let me go through the definitions of what you need to be a binomial distribution. And like I said, the book does a good job with this. So this idea in the shaded area is a random variable as a binomial distribution for a series number of trials. So the first thing that has to happen is there has to be a fixed number of trials. 10 people getting a coupon, for example. Say like you were taking an exam and there were 10 questions and they were multiple choice or true false. And so those would be examples of binomial style problems. And there needs to be 2 possible outcomes. So, and the variables are discrete. And so there's 10 people, there's 20 questions, there are 100 samples. So the variable needs to be discrete, and there are 2 possibilities. It's either success or we call it failure. And what we mean by success is that you get the question right, and failure means you get the question wrong. So questions that have partial credit is not binomial, but like true false questions or multiple choice questions, which either has a right answer or a wrong answer, those are binomial. An election is a binomial distribution, right? You either vote for somebody or you don't vote for somebody. The other things that are really important is the probability of each event has to be the same. And so if you're doing a multiple choice test and you have 3 answers, there's only 1 right answer. And so the other 2 are wrong. And so the probability of you guessing right would be 1 out of 3. And your probability of you guessing wrong are 2 out of 3. And that needs to be consistent throughout all the problems. You can't add more choices and make that binomial. Each trial needs to be independent, meaning that what you do in the first question or the first part of the experiment doesn't affect the second one. And with regards to notation, N stands for the total number of trials, and P stands for the probability of success. Remember, probability can be a number between 0 and 1. In this case, 0 and 1 are both very boring calculations, because 0 means it can never happen and 1 means it always could happen. So you'll see through there, these numbers are always going to fall between 0 and 1. So let's walk through a couple examples. Flipping a coin is always the first example. And say like you flip it 10 times. And so this is a binomial experiment. It fits all the criteria. First of all, the probability of you getting a head is 0.5, and then your probability of failure would also be 0.5. And so the idea of flipping it 10 times is a discrete and finite number. And there is flipping the coin the first time doesn't affect what happens the second time, what does the third time. So this is an independent event as well. Where on the other hand, this is not a binomial experiment. If you took 5 different people to shoot foul shots, and you let X be the number of foul shots that they make, this is not a binomial experiment. And the reason being is the probability of success for each person is different. For example, if I was shooting the foul shot and the next person was Steph Curry, I would think Steph Curry has a much higher probability of making his foul shot than I would. And so they're not going to be equal. And so in that case, if the probabilities of all the events are not equal, it's not binomial. And here's another one that's good, where if you had a box of 10 cards, 5 red, 5 green, and you draw 3 cards, unless you put the cards back in, right, the probability changes, because once you draw the first card, instead of having 10 cards in the box, now you have 9. So the probabilities will always be changing. Remember, we talked about the replacement aspect of that? And so this is, again, not a binomial distribution because the events aren't independent. Probability of the first one will affect the probability of the second. So here's what we're going to do now is talk about this idea of determine the probability and figuring out what the random variables are. And we always, at least I always start with a pretty simple example, which would be flipping coins. But before I do that, I do want to show you the formula. And you can see the formula becomes reasonably nasty in the sense that it's very tedious to calculate by hand. Some of you might not even know what C means, and that's the combination of n events occurring X number of times. And then you take the probability to the exponent X and 1 minus P to the n minus X. So that calculation becomes quite challenging. So I'm going to show you how to do one by hand. There's a bunch more examples in the books that shows you how to do it by hand if you're super interested. But let me do one here with this example. So you're tossing 3 coins, right? And so we know the probabilities of all these. And so let's say, what is the probability of heads? And so the idea of our variable is getting a head. And so how many possibilities are there? Well, do you remember? We're flipping 3 coins, right? So when you flip 3 coins, all right, there's 8 possibilities. So what is the probability of X is the number of heads? What is the probability of X equal 0 heads? Well, what would that be? That would be the one with 3 tails, right? So that would be the probability of 1 out of 8. So what would be the probability of X equal 1 head? Well, when you list those all out, you would realize that it would be 3 out of 8. And then the probability of getting 2 heads, X equals 2. would be also 3 out of 8. And the last thing is, what is the probability of getting all 3 heads? And that is, again, 1 out of 8. And just to refresh everybody's memory, I will write this up here and show you this is our sample space, right? Oops. And so this is our sample space here. Let's see. So 2 tails. 3 of those, and then the last one is tails, tails, tails. So you could see, you could count those all up. We walked through that in chapter 5 as well. So how do we use this crazy formula, right? This crazy formula of these calculations. And so let me write it up here. So it's the combination of n x, p of x, 1 minus p to the n minus x. Okay, so this term stands for what's called combinations. And in this class, we really don't go over combinations, permutations, etc. But I will show you again, just to put this together one time. So all these numbers look like this. Our n value is 3. And let's say we're going to calculate the probability of getting 2 heads. So we know what the answer is, right? This one's a simple one, so it's always nice to compare that. It is 3 out of 8. And so let me plug in all the numbers for you. So it looks like 3 combination 2. Our p-value, probability of success is 0.5, right? Of getting ahead. So that would be 0.5. And then our x value is 2, so we square it. And then 1 minus 0.5. And this would be 3 minus 2. So well, how do you do this combination? Well, you do this crazy thing called factorial. And so this would end up being 3 factorial over 2 factorial, and then 3 minus 2 factorial. And again, I don't want to spend a ton of time on this. We could spend 2 hours talking about counting and combination permutation. It's really not part of the curriculum, unfortunately. But like I said, most people don't do this by hand. I haven't done it by hand in decades. But the way this will end up setting up is that this would end up being 3 times 2 times 1 on the top. And then this would be 2 times 1 for 2 factorial. And then 1 factorial is just 1. So you can see this 2 will cancel with this 2. And then you get 0.5 to the 3rd power. We have 3 of them here. And you get out your calculator and do that calculation, you should get 0.375. And you can see that number in a fraction would equal 3 over 8. So again, if you got your calculator out and hit 3 divided by 8, you would also get 0.375. So you see that when things get more complicated, like say there were n is 10, right? And now we have a huge sample size, right? 2 to the 10th power. It is much easier to use the binomial distribution to make the probability calculations than it is to use the standard format that we showed you in chapter 5. So with that, so let's do the same calculation on the spreadsheet. And again, your TI 83 and 84 have these functions built in as well. So I popped up the spreadsheet already. And here we go. And so again, the most important is this idea of all these built-in functions. So you go up to the function. First of all, you should start over here. Let's click into a cell here. And so this would be probability of X equal to 2. So that would be 2 heads. So the way this works is you go into more functions and you type in binomial up here. And when you search for binomial, and hit go, you would see that binom.dist comes up. Super important. And so with using the spreadsheet for the calculation, you're going to have 4 different inputs. The first one is number underscore S, which are the trials. So I'm sorry, which is the X value. So in this case, we're going to plug in 2 for that. The trials is the N value. So we have 3 coins. So we'll plug in 3 for that. The probability is the probability of success, and it's going to be a decimal. And so here we'll plug in 0.5. And then this last one is cumulative, and you're going to use this a lot in the binomial. So cumulative implies that if you're doing an equal sign, you want to do a false, and it'll just evaluate the 1 point. If you're going to put in true, it's a less than sign. And we'll talk about the differences between all of that as we move forward in this section. So in this case, it's an equal sign, so we type in false. And you can see we get the exact same number. And so your calculator has a binomial function built in as well. And so you could use that to find this exact same answer. So that's going to end the first part of this lecture for binomial. I'm going to continue in the next recorded lecture to talk about greater thans and less thans and some little more complicated binomial problem as well.